Hello everybody, I'm Nick, and this time I'm going to take a look at reflections performance in C# and .NET and show you how you can actually improve it significantly to the point where it's comparable to something that would be compile time. Now, this wouldn't always be the case, and it heavily depends on what you're doing. And most of the time, you're going to use reflection in cold paths where you would just do some initial wiring up when your application starts, and then you're going to forget about it. But if you need to use it in a hot path, and sometimes you have to, I know I have, when I need to access something that a library wouldn't expose to me, but I really need it for something like logging or metrics collection, then I would need to optimize that reflection call. That being said, you also need to ensure that this thing doesn't break, because when you use reflection to access things that you're not supposed to access, it's up to the discretion of the library owner to change those things, and they're not considered breaking changes. So you have to be very, very careful when you update a library that you're using reflection on to make sure you didn't break something. But besides that, and besides all the safety nets you can put around reflection, I think it's a very powerful tool that you have to use with great responsibility. And it's something I personally use a lot, and I'm going to show you how you can optimize it in 3 ways in this video. If you like this type of content and you want to see more, make sure you subscribe and the notification bell to get alerted when I upload a new video. So what do I have here? Well, I have a main console application, which is basically our benchmark runner, because I'm going to show you a few benchmarks here as I'm showing you the techniques to optimize reflections usage. And then I have an external library here, which will act as the thing that we're trying to access. More specifically, we're going to try to get the value of this very private property. And I also have a public property here, and the reason why I do that is to provide a perspective on what a simple get compile time would perform like. So I have this as like my base for all the other benchmarks, and then I'm going to build around it to compare it with it. So the first thing you would do when you use reflection is the traditional reflection usage, especially in properties, where you just do something like traditional reflection, and then you would get the property info. Or actually, let's just initialize the class in the same way where we initialize it here. You initialize the class, and what we're going to get, just to understand what we're doing here, is the very private property. As you can see, we cannot actually use it. It won't compile. It won't let me. It's private. So in order to get access to that, I'm going to get the property info from that type. So I'm going to do some class .getType.get property to the property info. Then I'm gonna provide the name, which in this case is very private property. I cannot use name of because it is private. And I also need to give some flags here for the binding. It is an instance and it is non-public. So that should return the property info back to me. And then I can get the value of that. So I can say property info.get value and provide the instance of the class I want to get the value from. And I know that this is not actually null, and then return the value to string because I think it's object. We're going to cast it, and that's it. Now, just to show you how this works, I did not mean to run that, so let me just quickly stop this. I'm going to comment this out, stick a breakpoint here. We're going to say reflection usage.traditional reflection var value equals that, and if I change the debug and I debug this, and this is going to be the same for every other usage I go about. We create an instance. As you can see, the value is default by default, and then you get the property info. As you can see, we have it here, and then we get the value. As you can see, it's default, and then we return it, and the value is indeed default. So that's how every other way that I'm going to show you in this video will actually play out. And now what I want to do is I'm going to run a benchmark against this, which is the traditional reflection usage to get that value. I'm going to go back to my benchmarks. I'm going to create a new entry here, and I'm going to say traditional reflection. Here we go. I'm going to change that to release, and I'm going to execute this, and this will run all the benchmarks hundreds of thousands of times until we get consistent results. If you don't know what benchmark.net is, I actually do have a video on it. You're going to click on the top right corner of your screen right now to watch that. And results are back, and as you can see, The simple get, which we just have compile time, usage of the property, is returning on 6 nanoseconds on average, while the traditional reflection is quite a few times slower at 75 nanoseconds, so significantly slower. However, if we take a look at how we implemented the traditional way, you see that we get the property info every single time. Now, the property info is quite the heavy operation to get, and we don't have to get it every time. You can actually cache it into maybe a field. So what you can do to optimize the traditional way, if I duplicate this, is I'm going to say optimized here, is create a private static read-only property info, and then put that there and only get it on startup once. And I'm going to say cast property equals that. And to get the type, I'm going to say type of this, and I don't get type anymore. And here we go, we can use that. And now what I'm going to do is I'm going to add this in the benchmarks, the optimized traditional version, where we basically cached the property info in this specific case. And this is applicable to any other thing. Method infos, anything you're using can actually benefit of this idea that you don't actually need to evaluate something every single time. It's universally used. And I'm going to execute the benchmark again and see what we get now that we cached that heavy property info. And results are back. And as you can see, we trimmed off quite a bit from that original traditional reflection. We trimmed off 25, 27 nanoseconds. Not half enough, but almost half. So we did quite a lot of work here, and that's an easy way to optimize the traditional reflection a bit. But there's actually two more ways where we can go way further with this. You see, you can actually create in C# something called delegates, and it's very much the same as something like this. For example, you have a function that accepts a very public class and returns a string, and let's say del here, and then that has an implementation. This thing that can actually be defined here, for example, can actually be generated in code, and that can be used to speed up this very operation. I'm going to show you how you can do that. It will make more sense as I'm talking you through that. So in a very similar way, we are going to pre-cache something, but in this scenario, it is the delegate that will accept our instance of the very public class and return a string, which is going to be the property value. And to do that, I'm going to say private read-only is it static read-only? I think static read-only. Anyway, function that accepts a very public class and returns, yeah, I think it's the other way around. Here we go. And returns a string. Due to the nature of this, I'm also going to have to cache it. So I'm going to say get property delegate here, cast this and say delegate dot create delegate, and we're going to create the thing that we want to actually return, and we're going to have to specify the type of the delegate. So again, we're going to copy that. The syntax is a bit bloaty in my opinion, but it is what it is. So first we specify the delegate type, and let me just new line this so you can see it better. And then we're going to specify the method info that we want to invoke to get that thing back. In our scenario, it's the getter of the property. So in the cached property that we have here, it's the get method, and we're going to have to say true because it's a non-public get method. So this will essentially do what we need in compile time, but also using reflection, but it will perform as a compile time delegate. And to show you how this works, let me just quickly copy that. So I'm going to say delegate reflection, or maybe just compile delegate is also a decent name. And we have that. And then the only thing we need to say is return get property delegate, provide the sum class, and that's it. And just to show you how this would work actually before I run the benchmarks, just because you might be curious, is I'm going to say reflection usage dot compile delegate here, where value equals this, and I'm going to change the debug and debug it, and I'm going to step into that, and you can see we have the new class, the value is default, and then we're going to invoke that thing that we created, and the value is default, so we got that. But let's see how that thing performs compared to the traditional or even the optimized version of reflection. You can understand that this might not be applicable everywhere, but it might be in your use case. So let's take a look at how it performs. I will need to add it as well in here. So let me just duplicate this and say compile delegate here. And this is still very much reflection. It's just that we effectively mask it around the compile time delegate to get the performance that this has. So let's run this and take a look in a minute. So results are back, and as you can see, look at this. The simple get, the compile time version, 6 nanoseconds. The compile delegate, still basically using reflection, but around the compile delegate, 7 nanoseconds. We achieved almost compile time performance with that approach. Again, might not be applicable everywhere, and it does have its limitations, and we're gonna take a look at those now. But this is pretty damn good for this specific use case, and I've actually used this in production capacity because I just had to, and performed so well. So I hope you haven't seen this before, because it always wows people when I show that for the first time. It's just such an interesting feature. Now, it has its limitations, and the limitations that I see is the following. There's many times where you don't actually have direct compile time access to the type. So you cannot use this if this was, for example, an object, because you wouldn't know what the type would be. But then even if you could do it like compile time here, you still wouldn't be able to use it. It just doesn't resolve, it doesn't work with this specific approach. And there is an approach that works. Let me just show you exactly the problem, because I might be confusing you. So if I duplicate this and I call this very internal class, so an internal class, which is what we're gonna mark this, by the way, can't even be referred to. Did I just mess up the name? Internal. So this is now an internal class, and if I go to the reflection usage and I just duplicate this to show you what I mean, comment this out for now. If I change to a very internal class, as you can see, it just doesn't do it. And if I did something like private static read only type, and I said a very important class type, and I got it from the type .get type method, where I just say I think first is the fully qualified name, which is this dot very internal class, comma, and then the name of the library, namespace, which is this. So if I do this, then there is no way for me to properly cast the type here in this delegate to provide the same, basically the same functionality, and that's a problem. So in order to get around that, and I'm actually gonna keep this class type here, we are going to dive into uncharted territory, if you may, and we're going to emit IL code. Now, it's the least safe way you can go about this, but if you need this to be compile time, but also use a runtime type that you can't access in compile time, you have to do it this way. I'm going to simplify it, however, for us, and let me just quickly delete this and name this emitted IL version. I'm going to say that. I'm going to add a NuGet package called sigil, and sigil will make this way easier to implement. We effectively are going to be building a very similar compile time delegate, but this time we are going to be allowed to use a runtime type to implement that. So it's going to look like this. We're going to have a private static read only emit of a function of an object that returns a string, and I'm doing that explicitly to show you that you can actually do it without needing to have the access of the type in compile time. So emit a function that receives an object and returns a string, and we're going to call that get property emitter, and we're going to say emit that basically dot new dynamic method, and we're basically writing a method as we're going, and that method will be called get internal property value. So like we're gonna call it, but Okay, let's name it that. I'm just expanding so you can see it. Then this method doesn't have an argument, so load argument 0. Then cast class, because we want to cast it in the same way that we casting it here, but we couldn't before. So now we can, because we can actually get the type in compile time. We're going to use this type. Sorry, in runtime, we're going to use this type here. And then we're going to call the method that we want, which is the same method. It's the cache property.get method, true, and it's definitely not null. And then we just want to return. So it's a Fluent API around IL emission. If you don't know about IL code, I've actually made a video on that, writing hello world with IL, so you can check that as well if you're interested. So this thing will emit the code that we need. It does mean that we still need to create the delegate, and we're going to do that now. And it's actually very simple. All we need to do is say again, private static read only, and it's the same type. Actually, it's the same type as the thing we created. So it's this one. I'm going to say get property emitted delegate equals, and it's basically the get property emitter dot create delegate. And this will basically do the same thing as we did before, but we can now use a type that we get access to in runtime, and it can be internal, it can be anything, and you can use it. Dangerous works. So yeah, use at your own discretion. So now we are going to use that type to instantiate it. So I'm going to say internal class equals activator. I'm going to just imitate how this would be instantiated in runtime, but you don't have access to that. So we have the internal class, and then we're going to return using the get property emitted delegate, and we're going to provide the internal class here. And this will work. I'm going to show you how it will work by going in the program, commenting that out. I know this might look like voodoo, and you probably won't have to do it this way, but there is a path forward, and it's very fast. Let me show you. Reflection usage.emitted IL version var value. And again, this is accessing the internal class that you don't have access to in compile time. It's just a runtime thing that you can grab and use. So step into that. The initializer through an exception. Oh, it found the wrong. Oh, that's because we're using the cache property from the public class while we're using the private class. So let me just quickly copy that and show you the new version here. I shouldn't take cached internal property, and then this should be this. Yep, and then this goes here. So let's do this again. Here we go. Internal class, again, we just instantiated this class. You can see that it's the internal class that I have there that I don't have access to in compile time. And then if I do this and step over without any issue, I got the value. And now that I've proven I can actually do this, let's run the benchmarks and see how this new way, this exotic way of doing it, would perform. Let me go back and remove this and add it into the benchmarks. And now with that, you can basically do anything. You can access all those things that you couldn't do in compile time and still get, as you're going to see, compile level comparable performance with reflection at basically the expense of some safety that you can actually unit test around and guard around. Actually, wait a second, this wouldn't give you a realistic view because we're creating an instance using the activator, which is reflection every single time. So what I'm gonna end up doing again is caching it so we can only focus on the get bit, which might be unfair to all the other versions that create a new class every time. So I'm gonna extract that as well for the final examples. So I'm gonna say private side read only object this, and we're going to say new activator based on the type. So this goes here. Here we go. And then we are going to use that, so pre-initialized. And then for everything else, we're going to do the same. So private static read only very public class equals new very public class. And then I can just remove that, and I'm going to reuse it basically on everything. So here, here, and here, and here. Okay. Yeah, and I think that's it. Everything now is covered. So if I go back to my benchmarks, all of them are here. Let's run this again. And this should be more fair towards what we're testing. So results are back, and as you can see, with all the removals and all the improvements, we have the simple get returning in 2.7 nanoseconds within margin of error. They're very, very tiny measurements, those ones. Traditional is always the slowest, optimized is almost half that, then compiled delegate 3.4 and M80 version 4.2. This is all within margin of error. Basically, these three are technically the same. I mean, these two are definitely the same. This is always going to be a bit faster, but very, very tiny bit. So as you can see, three different ways to optimize, with one being very easy, one being a bit more complicated and more situational, and one being a lot more complicated and maybe harder to understand, but both of them are very, very performant to the point where they perform the exact same as compile time. So make what you want out of this. I'm just here to show you that this thing exists and you can use it, and it performs pretty damn fast. That's all I had for you for this video. Thank you very much for watching. Special thanks to my Patreons for making the videos possible. If you want to support me as well, you're going to find the link in the description down below. Leave a like if you like this video, subscribe for more content like this, and ring the bell as well. And I'll see you in the next video. Keep coding.